Now that you know how to use Desmos to find the line of best fit, we're going to talk about in this video how to make predictions using the line of best fit. Okay, so these problems will say something like, you see in example number 4, it says using the line of best fit, you're going to make a prediction with that. And so it could say something like that, or it could say using the linear regression model. Or it could say using the least squares regression line. They all mean the same thing, okay? And so it says in this problem, use the line of best fit to figure out how many billions this company will make in 2016, okay? So notice they're observing the years and how many in billions, how much money this company has made. So this isn't just $7.66. This is $7 billion. So this would be like $7,660,000,000. All right. So the first thing that you want to do is you want to pull up the Desmos app, and you're going to get the equation of the line of best fit. Okay. So since in my other video the sound was delayed, I figured it would be easier to do it this way. So just like you did in the other one, you're going to add a table. Okay. And then you type in your information. So let's see if we can make this one work, all right? So it's not really telling us how to type in our years, so we could actually type in the years as they look, or you could put in like a 0, a 1, a 2, a 3, so on and so forth, and it'll work the same, but when you're making your prediction, you're gonna have to type in a different number, okay? So I'm gonna type in my data, so we got 2000, and then 2001, so on and so forth. Just double check and make sure you type in things correctly, because it's easy to mistype something. Alright, and then type in my Y values. So we got 7.66. And now you can type them in how they look. Just be careful and make sure you remember that when you're making predictions, what these numbers mean, okay? So you're looking at the years, and you're looking at how much they've made in billions. And so just make sure you keep that in mind so that when you get your answer, you'll know what that number means. So we got 9. Wow, it's really hard to type on this. All right. So once you get your data entered, hopefully you guys can see that at least okay. I know it's a little blurry. But then once you get your data entered, you remember hit add, and you're going to add an expression this time, and you're looking for the line that best fits it. So it would be, you type in your Y, so I'm going to have to pull up my keyboard. And then remember you type in your 1, because it has to match the table. Goodness gracious. All right, and so notice I have an X1 and a Y1. So when I type this in, I'm going to type in my 1, and then you pull up your little tilde. So on this one, it's in the keyboard, and then it's MX1. So make sure you type in your 1, and then plus B. All right, so once you get that equation typed in, it's going to give you the equation, so you just write it down. So it'd be Y equals, the M is 0.23, and I would go at least, because you're about to use this to make a prediction, so I'd go at least 4 numbers past the decimal, so 0.2382, X, and then it's a minus 468.129. Okay, so that is the line of best fit. All right, so the other thing that you want to look at when you're making a prediction is you actually want to look at the R value, which is your correlation coefficient. So this is what we talked about the other day. So notice it actually gives you that too. The R in this problem is 0.7064. And so when you actually make your prediction, it's going to tell you how reliable that prediction is, okay? So we're looking for how many billions this company will make in 2016. And so notice that's an X value because that was my years. And so really, because you typed the numbers in exactly how it looks, you're plugging in a 2016 for X. So you're going to type that in. So I'm just going to pull up another equation here, and you're going to type in your equation. So you're going to type in the 0.2382, and then you type times, you're multiplying that by your 2016 because you're plugging in X, and then you're going to subtract the 468.129, okay? And then after you type that in, you've got your answer. So in 2016, how many $1 billion would they make? They would have made 12.0822. So the amount of money they would have made in billions would have been 12 billion. And then, so 12 billion, and that would be 82,200,000. Okay, and if you didn't know how to do that, you just multiply it times 1 billion, and it'll give you that. Okay, so changing that, it'd be 12 billion 82,200,000. That's what that number would look like. So that's a big number, okay? Now, how reliable is that prediction? Well, if you look over here, we talked about correlation coefficient tells you how strong those two things are correlated. So this would be more like a moderate correlation, and it's positive, so it'd be a moderate positive correlation. And so this prediction, I mean, it might be close, but it's probably not going to be spot on, okay? So how reliable is it? It'll be close. It will be close, but not spot on, more than likely, okay? Because the correlation coefficient isn't as close to 1 as we would like it, okay? So because it has a moderately positive correlation. All right, so I want you to take a second, and I want you to actually figure this problem out. So if you did this one, you would have typed in your table, then you would have got your equation, and your equation should have been y equals 30.5714x minus 60,590. Or if you typed them in differently, like if you type this in as 0, 1, 2, so on and so forth, then your equation will be different. But the answer that you get should be the same, okay? So you would have typed in, if you typed the years in like normal, you would have typed in 2016. If you type these in, like as in years since 1993, you'd have to figure out how far 2016 is away from that, and then you put that number in for X, okay? But either way, you should have got that they would have scored, because it's looking at how many goals, I guess, a team would have scored in that year. And so it would have been approximately 1,039 goals in 2016, okay? And then it's asking how reliable is that prediction? Well, you look at the R value. And so the R value in this problem, let's see if I can let you guys see that, is 0.999. So R is equal to 0.999. Well, that's really good. That's a strong correlation between those two things. And so this prediction would be pretty close to what it should be. So you would say it would be a good prediction because this is a strong positive correlation between those two things. So you would say this would be a good prediction. Be a good one or a close prediction. A close prediction. All right. So the last thing just says, or it gives you a table. It doesn't really even tell you what they're comparing here. They just label it as X and Y. And it says, what is the approximate correlation coefficient of the line of best fit for the data below? And then tell what it indicates about the strength of the relationship between them. So you will type this in, but anytime it's asking to describe the strength of the relationship, that's going to come from the correlation coefficient. So that's telling me right now that after I type this in, I'm looking for that correlation coefficient, okay? And it even asks you to find it, so that's kind of giving you a hint about that, all right? But anytime it talks about strength, make sure you find that, all right? So let me find it. So after typing in all of my data into Desmos and then finding the equation, I found out that the correlation coefficient was 0.9707. So because that number's fairly close to 1, you would say that this has a strong, and it's a positive number, so that means it has a strong positive correlation. So whatever these two things are that they're comparing are pretty closely related in some way. Now, they're not going to necessarily predict each other because it's not exactly 1, but you could kind of make predictions based on that data. Okay, so it has a strong positive correlation, and it's positive means that as one of those variables is increasing, the other one is also increasing.